Hello, my bomb blowers and module masters, and today I am here with another Keep Talking and Nobody Explodes modded module tutorial, and today I am here with the module Cell Lab looks incredibly daunting. There's a lot of text on the screen, and a lot of it's really hard to understand what it all means. In this tutorial, I'm going to help you understand what the text means and what you need to do to solve Cell Lab. Let's go ahead and get started. This module does not require any edge work, so as soon as the bomb comes in, we will begin work.
All available experts, please report to room A9.
This is Cell Lab. First, I'm going to go over each line individually and make sense of it all. The ID and the name are just bits of flavor text. You don't need them at all to solve the module. The edit mode line shows the current cell number you are on. There's M1, M2, and M3. These just correspond to the 3 cells that correspond to this module. There's also the cell type to the right of it. This cycles between all 6 of the cell types. This will be used later in order to solve the module. Next, we have this block of text, from keep adhesion to mode blah blah blah. The 3 checkboxes must be in the correct state to solve the module, and the modes are used to identify the cell type of the current cell you're on. Then we have this block of information. The split mass, split angle, child 1, and child 2 angle. For each of the 3 cells, one of these parts of information will be missing. One cell will be missing the split mass and the split angle, which is this cell. One cell will be missing the child 2 angle, which is this cell. And one cell will be missing the child 1 angle, which is this cell. And then finally we have the red color, the green color, and the blue color. This is critical information needed to solve the module. So, what do we do with this? The first thing to do is to calculate the hue, saturation, and brightness, the HSV. Each of the 3 cells correspond to one component. One is hue, one is saturation, and one is brightness. To figure out which cell corresponds to which component, you need to look at the part of the information that's missing. If the cell is missing the split mass and angle, which is this one, then this is going to be the cell that needs the hue value. So we're going to mark M1 as needing the hue.
Emergency cleared. All personnel, please return to your stations.
If the cell is missing the child 2 angle, which is this one, they need the brightness, so M2. And the cell that misses the child 1 angle needs the saturation. Think of it from top to bottom. In HSV, which is left to right in the normal HSV color scale, the top needs hue, the middle needs saturation, the bottom needs brightness. So we have which cells correspond to hue, saturation, and brightness, so how do we calculate these values? For each cell, they're going to need some tidbits of information. For the cell that needs the hue, which is M1, we're going to need the colors in ascending order from lowest to highest. So this is 72, 108, 254, as well as the order in which these cells are from lowest to highest. So it's blue, green, red for this one, because blue is lowest, green is middle, and red is highest. So blue, green, red. For the cell missing brightness, all you need is the highest number of RGB colors. 225 is higher than 46 and 106, so for this, we just need the highest number. And for the cell that needs the saturation, you need the highest and lowest numbers. So the lowest number is 31, and the highest number is 209. Now we can start calculating hue, saturation, and brightness. Let's go ahead and start with saturation. Hue is the hardest one to calculate, but not by much. For the one that needs saturation, simply plug in this formula. Now you may be wondering what C+, C-, C+ means. If we look here, minimum, maximum, and the value in between are respectively labeled as C-, C+, and C**. So minimum is C-, maximum is C+, and in between is C**. So if we take a look at this formula here, we can see it has a C+ minus C- divided by C+. We know that C plus is the highest number, which is this one, so let's go ahead and plug it in for C plus. C minus is the lowest number, so let's go ahead and plug in our lowest number. We get this number, remove all decimals, and this is the number that corresponds to the saturation. Next, let's take a look at the brightness, which in this manual is represented by Victor, but I'm going to write it down as Bravo in my notes just to simplify. For brightness, all you need to do is divide the highest color number by 2.55. So let's just plug this in, and we get this number, remove all decimals, and this is our brightness. Now comes the hue. This one is the most complicated to calculate, but not by much. So first, let's calculate O. O is not the final value of our hue. So we have the difference between the middle value and the lowest value divided by the difference between the highest value and the lowest value times 60. So let's plug in. Our lowest value is 72. Our middle value is 108. And our highest value is 254. This is our O. Now, how do we get the hue? First off, we're going to convert this BGR into one of these. This basically means the left corresponds to the red component, the middle corresponds to the green component, and the right corresponds to the blue component. Minus corresponds to the smallest number, 0 corresponds to the number in the middle, and plus corresponds to the highest number. I'll take this for example. So, from lowest to highest, it's blue, green, red. So, let's just go ahead and put 3 dots here. Just for reference, I'll clarify left equals red, the middle equals green, and the right equals blue. So we need to find which one red is, the middle, the lowest, or the highest. It is the highest, so therefore red must be represented by a plus. Next we take green. Green is in the middle, so it must be represented with a 0. And finally blue. Blue is the lowest, so it must be represented by the minus. Let's say we had, let's do another example. Let's just make up some red, green, blue values of 142, 234, and 61. So the lowest value is the blue number, which means the slot in blue is going to be the minus. Red has a number in between, so the red slot is going to be the 0. And green has the highest number, so the green slot is going to be a plus. This is how you calculate this. Let's get rid of this metaphorical. Let's take this and compare it to the table, which is this entry. Now I'm going to go ahead and explain one thing. Let me just highlight these in different colors. If your color had an odd position in the table, which is represented by the blue columns, then you add O to the left value. So if this was the one that corresponds to the cell that needs hue, you would add O to 0. For this one, you add O to 120, and for this one, you add O to 240. However, if your cell had an even number into the table, which is this, this, and this, then you subtract O from the right value. So for this, it would be 120 minus O, 240 minus O, and 360 minus O. So for our example, we had this one. We add O to the left value of 0. So 0 plus O is just O, meaning O is actually our brightness. We take the O floored, and this is our hue. Still with me? Next, we convert the HSV values into data. Let's go to the one that needs hue right quick, M1. You see that we need a split mask and a split angle. Well, simply, we just plug in. Let's take our hue value, plug it in. Now, it's giving me a syntax error. It doesn't know what this symbol is. Well, according to the manual, this is a floor function. It rounds down the value within the brackets. So I'm just going to convert this to a floor, which the text field calculator recognizes. And this is our data. The first number represents the split mass, which is 242. And the second number represents the split angle, which just so happens to be 0. So we can go ahead and set our cell information that we just gathered. Split mass is 242. Oops, I went over. How do I get back? Just keep clicking until it goes back to 242. And the split angle is, well, 0. Next, we take these two. These two correspond to the child 1 angle and the child 2 angle, respectively. So let's go ahead and plug in saturation of the saturation field, and brightness into the brightness field, and boom! The first number here corresponds to the child 1 angle, which is what M2 needs. No, M3 needs. So we can set the child 1 angle to 120. And then the second number of this pair corresponds to child 2 angle, which is 162, meaning we can set it. Oh, by the way, if you try to edit any of the predetermined data, the mod just simply won't let you. And then finally, we go to the boxes to check. There are a lot of floors here, so let me just go ahead and replace them with things the text field recognizes. And now we plug in our values. S corresponds to this. V corresponds to these. Now, what do these mean? The first number corresponds to the top box, the middle number corresponds to the middle box, and the right number corresponds to the bottom box. Now, it is important which of the 3 cells you plug in the information for. So we had 111. Let's go ahead and go back. The first and the last box correspond to the cell that needed the brightness, which for us is M2. Since these two were both 1, if the result of the operation was a 1, that means the box must be checked. And if it is a 0, the box should not be checked. So we have the top box checked and the bottom box checked, and that's it. You do not need to worry about the middle box. Now let's go to the cell that needs saturation, which is M3. This is where we take the middle number. It is a 1, so the middle box should be the 1. Should be checked. We do not care about the other 2 boxes. And it concerns to the cell that needs the hue, we don't toggle the boxes at all. They're correct, so don't worry about that. Leave them in their initial state. Please do not change them. Now we're almost done. All we need to do is figure out the cell types. And this is pretty much the most simple part of the entire module. This is a really easy process. If either of the children's cell number is the same as this cell number, you add 1. These are both M3, which is not M1, so we do not add 1. If for either of the other 2 cells who has a child whose number is the same as this one, you add 2. So we're looking for M1. Cell 2 has a child that is M1, so we add 2. And cell 3 does not have a child that is M1, so we do not add 2 again. If this cell had 2 children that were M1, we would only add 2 one time. So if this was M1 and M1, we would add 2. If it's M2 M1, we add 2. If it's M2 M2, we don't add anything. See how this cell doesn't have an M1 child, so we do not add 2. Meaning the final number for cell 1 is 2. 2 corresponds to FL. You can ignore the middle row entirely. It's not necessary, it's just flavor. So we set this to FL. Okay, that's unfortunate. That is actually really unfortunate that that's solved right then and there. CellF solves once all of the inputted information is correct. It just so happened that the other 2 cells had their correct cell type set already. which is kind of funny. Let me open up the log and show you how we would get the cell types for the other two. So, it says M2 and M3 should both be phagocytes, which corresponds to 3. So, let's take a look at this. So for M2, M2 has a children that it has the same cell number as the cell itself, so we add 1. M3 had a child that is the same as the cell we're focusing on, so we add 2. M1 does not have a cell, has a child that is the same cell number as the one we're focusing on, so we do not add 2, meaning this turns out to be 3, which just so happens to be a phagocyte. Same thing happens with M3. M3 has a cell whose child is the same number as itself, so you would add 1. Cell 1 has at least one child that is the cell that we're focusing on, so we add 2. It does not matter that both of the children are the cell we're focusing on. You only add 2 one time. And then M2 doesn't have an M3 child, so we don't add 2 again, making it 3. Let's do another one, but instead I'm going to focus on a method that...
All available experts, please report to room A9.
For this, I'm only going to focus on the cells that need hue and brightness. I'm going to ignore the one that needs saturation. So how do we determine the one that needs hue? You find the cell that's missing split mass and split angle, which just so happens to be this one. How do we find the one that needs brightness? You take the cell that's missing child 2 angle, which is this one. And if we were doing it the normal way, we would notate that M2 is missing child 1 angle, which means that it would need the saturation. But we're going to ignore that for now. So for M1, we're going to get the same read we did last time. The numbers from lowest to highest, which is 13, 99, and 126. And the color components from lowest to highest, which is blue, green, red. Just so happens to be the same as last time, which is not really good for showing off the module, but oh wow, I'm not going to complain. And then we go back to M3. If you remember, the brightness just needs the highest numbered, which is 231. Does not care about anything else, just the highest number. If we were doing the cell that needed saturation, this is just a what-if scenario. We would take the lowest and the highest numbers, which is 44, and oh looky! We have a tie here! 142. Because it is the highest value. It just so happens it's also this value in between. Let's go to the hue entry. Let's say this just so happened to be the one that needed the hue, which it's not, but still. If there are ties, which there are, pick the first entry in the table in reading order that applies partially. So for this one, we have the lowest is definitely green, but red and blue are tied. So let's take our calculations to determine what the 0, minus, and plus is.
Emergency cleared. All personnel, please return to your stations.
Well, we know green is the lowest either way, so that's going to be a minus in both cases. In the first case, R is in the middle, so that's marked by a 0. And since B is the highest, we mark the B slot as a plus. Basically, for the second one, we just swap it. Blue is marked in the middle, so we set the blue value to 0, and red is the highest value, so it's marked as a plus. We compare this with the table. This is the first entry, and then this one. This is the second one. We would take the first entry in the table in reading order. That applies, which is the blue entry, so we ignore the second one and we use the first. This is a what-if scenario. This is not what we're supposed to do for this particular cell lab. We're just doing this for what-if. Anyway, back to actually calculating stuff for cell lab. First, let's go ahead and get the brightness because that is the easiest thing to get. We take the number we got from the cell that needs brightness, and voila, this is our brightness. And we go back to the hue. We have blue, green, red from lowest to highest. So let's take RGB. Blue is lowest, so we mark it with a minus. Green is in the middle, so we mark it with a 0. And red is highest, so we mark it with a plus. This is what we use in the table. and this is the entry we're using. So, now we calculate O. We take the middle value for C asterisk, the highest value for C plus, and the lowest value for C minus. This is O. Because this entry has an odd index in the table, we add it to the left value, which is 0. O plus 0 is still O. Oops. O plus 0. So we take the results, floor it, remove decimals even, and that's our hue. I'm going to go ahead and use a different example since we got this both times. Let's say that our cell had this. No, this. And let's just say we have the same O value of 45. Because this has an even index in the table, we subtract O from the right number, so we take 240 minus O, which would result in 194. And once again, let's say this applied. Because it's an odd index in the table, number 5, we would add O to the left value. So instead of it being 240 minus O, it would be 240 plus O, meaning the number is 285 for hue. But that is what if. Our actual hue is 45. Let's do some calculations now. We're ignoring the one that needs saturation. So first off, we get the split mass and the split angle for the one that needs hue, which is this one. We plug in 45 for hue, we convert this to a floor, and we get the values of 0 and 45. 0 and 45. Now let's go to M3. We have... Since these two are the same for figuring out child 1 and child 2, it doesn't particularly matter which one you use as long as you just plug in the correct number, which is 90. And 195 corresponds to the child 2 angle for this cell. Now, we get the boxes. Because we are ignoring the cell that needs the middle box, we only care about the top and the bottom box. As you can see, the calculation for the bottom two boxes is the same, so once again, we can just copy the first two equations, convert these to floors that the text field recognizes, we plug in the brightness value, and we get 1, 1, meaning for the cell that needs the brightness, both of the boxes should be checked. 1 and 1, we ignore the middle box. Now let's get the cell types. For M1, none of the children match the cell number, so we move on. None of the children match the cell number, so we move on. One of the children matches the cell number. Because this is not the cell we're focusing on, we add 2, meaning cell 1's final value is 2. Now let's go to M2. M2 has at least one child whose number is the same as this cell, so we add 1. M3 also has a cell whose number is the one we're focusing on, so we add 2 because it's another cell. And M1 also has a child whose cell is the same number, so we add 2 again, meaning the number for cell 2 is a 5. Let's go ahead and convert these two subtypes before I forget. So 1 is 2, which means this is an FL. 5 corresponds to DB. And let's get the value for M3. M3 does not have a cell child whose number is the same as M3, so we skip it. M1 does have a cell whose child is the one we're focusing on, so we add 2. And M2 does not have a child whose cell type is the one we're focusing on, cell number is the one we're focusing on, so we skip it, meaning the final number for cell 3 is 2, which is another FL. Let's go ahead and set these. And something to note, if you can remember this, this would be good, because the diffuser can potentially solo this part. The cell types scroll in the order of 3, 2, 4, 5, 0, 1. It starts on 3, then it should go to 2, which is FL. It goes to 4, which is PT, then 5, which is DV, then 1, LP, and then, 0, my bad, and then 1, which is KT. The module will always consistently scroll in this order. Let's go ahead and set our cell types. But wait, the mod's not solved. You remember the cell we skipped? I forgot which one it is, honestly, so let me go back. It's M2. Well, the module can't strike us, right? And the module solves when all the information entered is correct. So theoretically, if all of the other information is correct, if we just cycle through the angles and have the box, the middle box in the correct status, the module should solve, right? So the box is unchecked correctly. And the module solved. Interesting! You can completely cut the calculations for the cell that needs saturation. This is just a strategy to use if you're familiar with the module, but it saves a lot of time by skipping out calculations entirely. That is it for the cell lab tutorial. I know this was brief for a rather complicated module. Please tell me in the comments if you have any questions, and I will see you next time.